Morning, Nathan. How's it going?
It's going very, very well, Jude. Yeah, it's good to see you again.
It's been
It's been a
some
long time.
years since we were both at
Yeah.
Dyson, but it's always interesting to have an excuse like this project to get back in touch and hear how things are going. So thanks for taking the time this morning.
Oh, yeah, very welcome. Very welcome.
So let's just assume anyone might need just a quick refresher. Basically, I had sort of posted on LinkedIn a little bit of a precursor to this project, which was around fixing my headphones, which have, of course, these little lithium polymer batteries in them. And going down this rabbit hole, I realized that basically these things are quite complex, quite dangerous. And as much as I would love to encourage universal right to repair, there's a little bit more nuance in it. And so I was aware that you have worked on some pretty intense battery management technology at your times at Dyson. And indeed, we'll get into where you are now. But I thought that would be a really good thing to sort of, as I said, level up my knowledge and indeed share that with the people watching this video.
Yeah, sure. Absolutely.
Brilliant. So maybe we could take it from a top. As I alluded, we met at Dyson, but could you give us a little bit of a sort of summary of your career and indeed why you love doing what you do?
Oh, wow. I've never been any good at anything else. That's why I love doing what I do. Um, I, you know, my first experience of electronics was my uncle used to run a TV repair shop in Cardiff years and years ago. So I've been kind of smelling lead solder since I was, in single digits. So that, I mean, that's kind of my background. I got into electronics really early. I've loved it. I've not really ever wanted to do anything else. We met while I was at Dyson. I spent 20 years at Dyson designing products, running research, um, looking at how to bring new technologies in and deliver um, or enable features for Dyson products. I've recently moved on from Dyson. I'm working for a company called Atlas Magnetics, where I'm a consultant for them at the moment. Um, their focus is on power management and kind of micro ASIC design. So it's all about shrinking electronics and trying to deliver um, a kind of market leading performance for efficiency and size, which has a massive impact on kind of the green footprint for electronics. So I'm interested in that because I've kind of got an environmental conscience, and that's where I want to drive it. And that's why I picked up on your post, which is where our conversation kind of started again. So that, yeah.
And maybe actually just one of the things I'm acutely aware of is essentially when I was discussing my headphones, as I mentioned, this was a single cell. So you can see that basically if you take this apart, not that you should, but you can see that basically this is one package of all the sort of chemicals and various lithium and polymer stuff. And it has essentially two cables, one of which an additional one is to do with the thermistor. Now, I would say this is sort of reasonably elementary, but when you consider the packs that you were doing on, say, the Dyson handheld vacuum cleaners, these had multiple of the round ones all put together. And so I wonder if you could just describe a little bit, apart from the obvious of that there's more power, why is it that this is a more complex thing? What happens if one of those cells goes wrong, for example? How do you manage that?
Well, cells in their form are different, right? So there are different failure modes for the little pouch cell that you just showed on the screen, and the kind of 18650 type cans or larger that we're seeing in kind of a higher power products. Um,
Yeah.
Power density is fundamental to the kind of level of risk involved. Yeah, so it's an 18650. So the power level is fundamental to the risk. The electronics that you wrap around to deliver safety changes as your risks increase. Um, if you took apart a pouch cell from depends on which brand of headphones you were going to disassemble, or or mobile phone you disassembled, you might find that they've built in across that top edge of that strip in that battery pack some safety electronics and some safety circuit. Um, as you stack cells up in number, as you start to increase the cells. You tend to charge those cells in series and discharge them in series. So what happens is the differences between each of those cells get amplified over the lifetime of charging and discharging, which is where I instantly get worried when somebody goes, can we make this pack a right to repair pack? Can we give people the right to change cell number 4 out of a stack of 6? Because how packs are built and how they're balanced and how they're put together is very carefully managed by the manufacturer. It's very carefully managed in terms of they're built as a pack, as a group of cells that have been selected and put together. The aim is that they age together. So a cell at beginning of life towards end of life will have completely different capacity and ESR. So if you put a new cell or a different manufacturer's cell into a pack, bad things could ensue. Right. So it's because there's an assumption that cells will age or be built. I say bad things could ensue. That's if it's not managed properly, right? So
the bad things such as fire or just thermal,
well,
just sort of deformity of the appliance, I guess.
You did a breakdown on a DC34, your DC34, and
Yep.
you had a look at the battery pack in that. The guys who designed the safety circuits and the strategy for safety for that product, if we took it apart, towards its end of life, and we replaced the single faulty cell in that stack and we put it back together again, it wouldn't result in fire or some catastrophic type disaster, but it would just disable itself very quickly. It would, through that charging process and discharging process, we'd end up with an imbalance. That imbalance would be sensed and it would brick itself. The pack would effectively, the safety electronics would kick in and it would disable the product. So you might feel like you've done a repair on a pack, you've extended its life, but actually all you've done is a very temporary thing, and it'll end up stopping working and stopping working and stopping working. And I think that's part of the issue. I think with how right to repair is written, you have to be approaching how we repair products from the right point or the right outcome for the user. So changing individual cells in a pack that's balanced, that's been designed or built to deliver a product performance for a product lifetime, it's probably not the right level of granularity for a repair. Actually, what we should be doing is sending that pack back to its origin. So Dyson has a scrappage scheme, and it will take your old pack off you and sell you a new one, right? And all pack manufacturers should be or regulated to do that. So our right for repair, in my opinion, if it's a multi-cell product, should stop at that battery pack state. That gives us different kind of approaches, right? So where right to repair is also designed, or we are thinking that it will impact how products are put together and how they can be taken apart. And we're hoping, if I'm a legislator, I'm hoping that will also assist with my end of life breakdown of the product and its recycling. So I think that's a naive boundary to think that actually we'll bring in right to repair and that will help our recycling centers and our service centers do that kind of breakdown of product end of life. And actually that needs to be regulated differently. So I think those are kind of key points to kind of pull out.
And would you say that maybe, I appreciate this is going back to a single cell scenario as opposed to a multi-cell, but the original battery that I took out, this of course is not really intended for repairability, whereas this is just from a generic sort of mobile phone. that there was some sort of probably about sort of 10 years old. And of course, it has those little contacts that you can pop in and pop out. Indeed, companies like Fairphone have made a virtue of this. And I think one of the questions I thought would be good to discuss with you is, it seems strange that we're discussing an old technology, an old approach, almost needing to be revisited. What would you say are some of the nuances that we're not just, as it were, going back in time, for a sort of nostalgic view of good design? What would you say are the sort of new advances that we need to take forward as well, to make sure it's a fully considered proposal?
Um, well, you picked up on um, in your blog on how lithium batteries or cells are often designed or customized to the application for the product.
Yep.
Some of that is about designing cells to support, a sexy product architecture. So, and it's the bit the mechanical bit, the bit that wraps up the electronics is not my bag, right? But um, you know, you I've read some teardowns on some laptops and some mobile phones and some other products in the kind of wearables, hearable space from Dyson doing the Dyson Zone. Um, and what we're seeing is that they're using every extra small area of space to place cells.
Mm-hmm.
Often there's two or three cells of different sizes and different shapes that are squashed into kind of spare cavity, or you're trying to use the space, and that delivers great product, right? It gives that kind of feel in hand and the things that drive and sell products. Um, it is something that electronics tends to, the guy who's designing the electronics turns up to enable at the end, right? It's
Sure.
not it's not a consideration, so right to repair isn't a consideration at the beginning of design, and it probably should be. I think um, when products were in their infancy, I mean, I had my Nokia 3310 phone for 10 years, right? So, um, and I say I had it for 10 years. I probably bought 3 batteries for it in that time. Um, uh, but um, you were able to do that. You could take the back off. You could, you wanted to change your provider. There was a SIM card that you could take out and you could put a different SIM card in it, and you could swap your service provider. We're getting to the point where we're going to see eSIMs become virtual SIMs. Batteries are being built into phones, and the ability to strip things down and change things is a compromise that then becomes like the thickness of the phone, how it's
Mm.
packaged. It's impacting consumer choice. So it's difficult, but it should be done. It should be done. We should be legislating that the approach means that people should be able to exchange a battery in a product. Um, so I'm all for that. I think those kind of things are pushing us in a route of being more sustainable. Um,
Yeah.
some of the smartphone guys where they're designing uh, almost like a backplane where you can upgrade your camera or your memory or your um, taking that to an extra step so that it's not just the battery that becomes replaceable, but actually you have a platform that you can, evolve and upgrade, and there's no reason for that not to work, right? The camera market has been there
Mm.
for doing that for, you know, 30 years or something, so and it's great, right? It will enable choice eventually, I think,
Mm.
if we can take that on. Um, but it does limit the size that we can reduce product to.
Mm. I think one of the the phrases I had in the blog was, embrace the chunkiness. And what I
Yeah.
meant by that was, I appreciate if you're designing AirPods, probably someone at Apple is thinking, well, that's nice, but I just have no ability to put the genie back in the bottle, the toothpaste back in the tube, metaphorically, of just it's impossible to really work with this scenario. As much as I know there are actually some in-ear headphones from Fairphone that actually sort of would be a useful counterpoint to this, I think the thing that I'm trying to get at is essentially, do you think we need a different form of standardization? Is there something that the legislation is looking around right to repair, but there's a secondary part, which is how to also put pressure on the fact that I think I sort of mentioned in my blog, there's over 5,000 different SKUs of LiPo battery from one company alone. And I'm not saying that designers should have to make do with just 10 different flavors of battery, but is there a middle ground between 5,000 that means maybe there should be like 100 or something like this? Or do you think that's a little oversimplistic?
I I think we should focus on um, the interface between
Mm-hmm.
between battery or cell and product.
Yep.
Um, um, a few years ago, that I think it was a company called Volt. I might have got that wrong. I might have to find the link and send it to you.
Don't worry.
But they they were building the tiny switch mode power supplies into the top of um, the AA cell, right? So they're
Yes.
giving you a serviceable replacement for an AA cell that you could recharge, and you could use that cell everywhere, right? So the
Is it
technology
similar
or
to
the
these ones here, which are a 1.5 output, but actually have 3.7 volt technology inside them? But
yeah,
this little line at the top is basically all circuitry if you were to hack it open. Not that you should.
yeah, but yes, so the companies that are approaching and trying to do that show that actually battery to product interfaces can be standardized, right?
Yep.
So your ability to say, and we're seeing, Atlas Magnetics are doing kind of magnetics in glass. They're going to make them really tiny and small, and they're going to revolutionize switch mode power supply design. I say that because I'm working for them and I've seen some of the heats of the things that are coming. Um, they're not the only ones that are trying to drive that marketplace. Um, but if we can standardize the battery or cell to product interface, we can add some DC to DC. We can look at how we manufacture products so that they have that kind of standard 3.3 or 1.8 volt into products. Um, it does make the battery or cell a generic item. It means that regardless of whether it's from manufacturer A or B or C, it can be slotted into a product and just operate and function.
Mm.
You know, um, Nokia did that with the 3310, right? So my first battery was probably NiCad. The second one was nickel metal hydride. The third was lithium, right? But
Mm-hmm.
they all fit. They all did the job. But you're right. You do have to embrace the chunkiness. So, um, but we need to think about legislating that as a kind of as a the detail of the design needs to be there. And unfortunately, the groups of people that are involved in setting out the sustainability legislation and right to repair legislation are often not the most technical people from the companies trying to influence, um, the consumer bodies or drive the legislation. Sometimes this legislation is written more as protectionism than
Mm-hmm.
it is about driving that kind of green um, uh, vision, I think, for where we want to go. Um, so if you look at France's right to repair legislation or the EU right to repair legislation, they talk about who can repair it and then being a qualified person or it being a qualified centre. That's about um, really that, without any definition. And when you drive into it and you push the bodies about what that means, they mean it's somebody with insurance based
Mm-hmm.
within the EU. So what does that do? It generates jobs in the EU. It 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 creates an environment where your company has to legislate or approve repairers.
Yeah.
So it's generating an environment that is very kind of European centric
Hmm.
and will stop. Perhaps they're trying to stop maybe an influx of cheap Chinese products or cheap Asian products, you know. Um, but actually, that's not what the legislation's for. The legislation should be about being green and should be about how the products are stripped down and how
Hmm.
well product is designed. You know, it shouldn't be about protecting a market so that only Europeans can design and sell to Europeans.
Yeah.
Um, so we need to approach it in a way that is honest, and then it'll be respected by those markets.
Yeah, I think one of the things that surprised me about going to sweep Kusakoski, if I got my pronunciation correct, of the UK's largest processing plant for these sorts of things, for electronic goods in the UK. It was notable actually that there was another battery pack that was inside a handheld vacuum cleaner, and you didn't actually need a safety screw to get it out. You could just basically use considerable finger pressure and pull it out to eject it. So as much as I sort of was reflecting on that, because obviously we'd both worked on Dyson, which has a Phillips screw to basically ensure that it's an adult doing this and that it doesn't accidentally just drop out because you dropped it on the floor. This for me actually exemplifies a bit of a sort of gray area of, by making it too easy to get out, you can incur risk as a company. But at the same time, if you have too many screws and tricky bits, of course, sweep and places like this have a bit of a headache getting it out. So do you think that, again, part of the reason I sort of started this blog, and maybe this is a good time to sort of discuss tips and tricks, is not to actually come off as an authority on this, but to say these are some of the things which, ostensibly people are trying to say this would make it easier for the whole holistic picture, better for the user, better for end of life, and indeed better for repairability and replaceability of batteries. What's your reflections on, should we say, just a better design practice to these things?
Mm, It's a really good question, Jude. And I think, all electronics has a lifetime associated with it. So, um, designing products for a lifetime is what, the consumer electronics designer does. It's what the aircraft engineering electronics designer does. We're all battling with a lifetime. That lifetime's normally far longer than kind of the electromechanical or mechanical kind of is and assemblies. They're we normally feel like we've got an easier time of it. But actually, if you look at an electronics assembly that's doing motor control or battery management, there could be a few hundred components that build up that
Mm-hmm.
circuit. Some of those will have an aging process that is related to temperature. So, um, you know, we're there's a there was a guy called Arrhenius who did, there's the Arrhenius equation, which will talk about how you manage or you build those kind of lifetimes, or you measure that in terms of aging and temperature and all those kind
Mm-hmm.
of things. Um, so so products, if we design a product, we're designing a product to a product life. Um, if I was designing products for somebody at the cheaper end of the market with a 2-year warranty, I'm going to make different choices to if I'm designing product for a product with a 7-year life or a 7-year warranty.
Mm-hmm.
So the guy who's designing the electronics in a Kia, your Kia car that comes with a 7-year warranty when you buy it, will have, you know, made a different set of calculations to
Yep.
the guy who you buy your Ford off, right? Not to pick on people, but that's the kind of, what other
Yeah.
manufacturers are in the mix, right? Um, and it's important, right? Because your design guide points um, is going to set your reliability, and that has an impact. So for the legislators, I would rather I think right to repair is a really important thing to encourage. I think it's great. Empowering users is great. Having people having the ability to swap out kind of components that age is great, whether it was a washing machine or your motor car or your smartwatch. I think is that they're all valid arguments, right? Because why not repair it, right, and keep it going? Why not increase its life? But it should be the change that enables an extension of life. It
Hmm.
should be so it shouldn't be you shouldn't be paying Peter to rob Paul.
Yeah.
Um, it should be an honest trade. It should be thought about as an honest trade. You should be enabling things. That should be done by design. It should be built in and baked in for the designer to have rules to design to. Um, some miniaturization and some drive to make things smaller will enable that. There's a bit of electronics here. The big electrolytic capacitors, the metal cans that look like tiny batteries. Um, these are wet components, and batteries are wet components often as well.
Yeah.
That have an electrolyte. So as you thermally cycle it, the electrolyte is going to dry out. Their internal resistance of those components is going to go up. That's going to drive internal heat, which is then going to make it dry out further. That has an impact. That means that we are designing products with a finite lifetime that is temperature related. So tips and tricks for designers: look at what we pick, what components we pick, how we design to a 7, 8 year life, right?
Hmm.
Um, I know there's advancements in solid state batteries. Solid state batteries are going to have a massive impact on the
Hmm.
lifetime of cells because the wet electrolytes and those kind of things that sit within those components is going to change. Um, Driving size and space using kind of newer switching architectures going up in frequency for designs will have a massive impact on the use of electrolytic capacitors in products, which will have an impact on life of product. Um, One of our mutual friends at Dyson, which we won't name without her permission, did her PhD on um, the right time to change your product in order to be green.
Mm.
Um, and by that, if you think about how the industry evolves, products are constantly becoming greener. The market is driving better use of energy in a marketplace.
Yeah.
Um, and she published a PhD maybe, I don't know, 15 years ago, something like that. The outcome of that study at the time was that you should change your washing machine every 8 years
Hmm.
because actually it's it will pay for itself in terms of the saving it make in the energy consumption over that 8 year period because um, your detergents have advanced, your motor drive has advanced, your
Hmm.
method of heating has advanced to the point where it will pay for itself. Now, whether it pays for itself in terms of CO2, we need more studies, right? Um, but I think legislation should be written
Hmm.
off the back of people running studies that
Yeah.
really look at kind of CO2 debt, energy debt, and there will be a right interval for saying, well, actually, it's time for these products to die or be taken off the
Hmm.
market and
Hmm.
replaced for the sake of the planet, right? Um, which is good, right? Because it works with consumerism, that argument, so it's more easy to sell. Um, but it's probably going to be longer than the interval that we want from as a as a as engineers that make our money out of selling consumer products. Um, so an approach like Fairphone, where or modular type design, where we're enabling kind of replacements to be designed for and built for, and we're we're encouraging a marketplace where you're selling, you can sell new battery technology into it in 5 years' time, has got to be something that enables people to make those types of choices. Um, we should really be legislating for things like standby power, the energy used building a product,
Hmm.
the energy used to disassemble a product at its end of life, as well as encouraging right to repair. I
Yep.
think, and we need all of those things to be considered side by side in order to have kind of a holistic design approach. Um, Tips and tricks, I think, from designers, from my point of view, from products, you know, with that being absent, we should be starting to do it. We should be publishing our thoughts and our process in the
Hmm.
absence of legislation. Um, we should be engaged in the narrative, which you're doing, which is amazing. And your kind of Flight to Repair blog is amazing for bringing people along and encouraging them to look at, how to design with a social conscience, how to design products that enable people to extend their life is great piece of the argument to take and push.
Mm.
Um, yeah, so that's kind of
I
hopefully that
guess
answers your question.
I guess one of the sort of the things that, having been in, again, we won't draw attention to specifics of internal decision making. But of course, one of the sort of intimidating things about trying to do the right thing and being transparent is that for companies, it can just feel like, a sort of way to a hiding, that essentially you sort of go, well, we did the right thing. We published all this data and everyone's just tearing it apart and criticizing us, as opposed to if we just kept quiet, stuck our head in the sand and carried on like all of our competitors. So it does feel like it's a really hard gambit to just go out there first and say, yep, this is it. It's not perfect, but here we are. This is our version one. Next year we hope to do better. But I think one of the things that is often sort of missed in some of these arguments is that it's not really just all on consumers, it's not all on designers, it's not all on legislators. It is a very circular thing. And I wondered, it feels like I'm reminded of when I read Shoe Dog, Phil Knight's Nike, whatever you call it, sort of story, which has, of course, a little bit of sugar coding and a little bit of his own polemic take on it. But I did like the point that he was saying, even when they got things wrong, the transparency was endearing people to the brand. That they said, you
Yeah.
know what, that was a terrible shoe. We're really sorry. We completely messed up the arch of the foot. We've learned from that. Thank you for your feedback. We're going forward. And I get the sense that Fairphone is one of those companies which it isn't trying to be perfect. It's trying to engage people. And so I wonder, do you think we will see a new breed of design companies and brands that are trying to create discussion in absence of perfect legislation, should we say, which will never exist, really?
Well, I really hope so. You know, um, and I'm an iPhone user. I hold my hand up and say I'm really sorry, but uh,
No, same. I've owned that one as well.
and if you have to, you know, um, so from a consumer point of view, everybody's got to make a choice, right? And I would encourage people to make ethical choices. I think Fairphone, and there are others that we kind of like listed in our chat, you know, that 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 are looking to deliver kind of an ethical kind of approach to how things are done. You've got to be honest, right? If you look at how ICs are made, it's a huge amount of energy that is
Yeah.
poured into um, heating and purifying silicon in order for it to be turned into microchips. They do a huge amount of air miles in terms of um, their journey from die to package being placed on board. Um, as a consumer and as a fellow human on the planet with children, I want to have a see grow up. Think about your choices, right? Buy less. Does it need to be a battery product? Um, I sit and you and I sit and we're in conference calls all day long. Do I need wireless? Do I need a a
Hmm.
wireless headset? Do I need a wireless keyboard and a wireless mouse? It's nice because your desk is tidy and you have less wires. Do I really need it? Um, so, everybody should think about their choices along the way. I'm not saying, you know, don't fly or, go back to eat the whittling wooden spoons, right? The
Sure.
technology will play its part in the answer, as well. How we approach things and how we drive things to be ethical will
Hmm.
will be important. Doing more with less is always, a good approach, and right to repair is making a good stance in terms
Hmm.
of, it's flawed as a piece of legislation, but it's a good approach to getting in there and doing that. Um, but it'll be simple things. It'll be, we're involved. We've ultrasonically welded lots of bits of plastic together that mean that um, to replace or repair a bit of electronics becomes impossible. You
Hmm.
know, there's a push to make things waterproof, which it make recycling the product or repairing it really difficult. Um, you know, Stop it, right? Wireless charging is an environmental disaster in terms of the energy from point to point. Um,
Just to
uh,
clarify on that, you're meaning the inefficiency of having two coils near each other as opposed to a hard connection.
in terms opposed to a hard connection
Yeah.
can. Um, but then there are companies like Electronic that are pushing efficiency for wireless charging to a new level.
Mm.
So, um, should we scrap the idea of wireless charging? Well, no, but should we actually think about where it's necessary, and then should we try and set ourselves targets that drive us forward? Yeah,
So,
absolutely.
so could I maybe sort of get into sort of actually a bit of a case study? And this isn't a sort of I don't know what the equivalent of nepotism is or bias towards Dyson, but genuinely, I did find it an inspiring thing when I joined the company, that Dyson was basically lobbying for a counterpoint to the legislation around efficiency of the electricity used to generate the cleaning suction power, and it sort of invented this term called air watts. Otherwise, in absence of this, I'm trying to explain it simply, is that someone could come along with a really big, inefficient, hefty motor that's drawing almost kettle levels of electricity and say, "Oh, look, it's got better suction, it's a better cleaner." Whereas Dyson was trying to say, "We're trying to get really, really good cleaning with using as little electricity as possible." And Dyson, of course, didn't invent this notion. If you look at any appliances, you have this A to F grade or whatever on efficiency. Or indeed, another metaphor, just to abstract it a bit further, is it took us a long time to have the traffic light warnings on for salt, sugar, fat on products in supermarkets. I guess where I'm driving with all of this is I don't think consumers really want to think and read through hefty bits of legislation, like this bad boy. It's a case of, can we simplify it and can we create simple traffic light level indicators to say, look, this is a well-designed product. It's got a 5-year warranty for all the right reasons. And we hope that you love it and cherish it and repair it. And it's got this repairability score as well. Does that feel like something which genuinely the needle starting to move that way, or is this still very much just hipster brands and student design projects are going to focus on this?
No, absolutely not. I think
Good.
we're going to see. So, we're going to see, Dyson has been involved in driving sustainability legislation. They've got a whole group there, dedicated to delivering sustainability. Um, and it would be great if you could get one of those guys from that team to talk to you, guys and gals, talk to you. Um, uh, yes, sustainability is going to be a big thing. I think we're going to start to see it taken really seriously. Um, my worry is that, again, it's about defining the right boundaries
Mm,
around what is a product. So, um, consumer products that use batteries would normally consider everything that turns up within the box as the product. Um, Whereas actually it's much more subtle than that. The the wall wart that sits in the phone, the plug that does the power conversion that gives you your connector to plug in your product is a product. Your battery pack separated from your device that can be, when Dyson's moved away from putting screws in things to having releasable catches so they can ship products with multiple batteries and swap them out and stuff. That battery on its own is a product. It means that the thing that's doing the suction or the blowing or whatever it is for, to use a Dyson type vernacular, or the bit without the battery and without the thing that's charging the product is also a product, and
Hmm.
giving them all their own label is a really important step towards delivering good design, right? So whether it's energy labeling or it's sustainability scores, the minute we start to get into right to repair and we modularize everything, all of those different bricks all need their own label. And that's something that the industry and the people who are trying to define the legislation are resisting, but actually it would be a good push there to make that happen. If this, so our concept of what product is, our concept of what sustainability is, as in, because it's going to be built. So, Fairphone kind of example would be exactly the same, right? So, your camera module or your battery pack or your, backplane that is connecting everything together. It's almost like they all need to be their own individual product.
Hmm.
We need to be talking about scoring multiple bits of assembly, and then giving people a nice way of looking at a kind of holistic score for the system that they bought. Um, that would be a massive improvement on where we are. Hopefully they get there. Hopefully we're able to push them along.
No, I mean, I think that's and again, I'm conscious of your time and that you've got to go, but it feels like you were sort of, broaching on the last question we would discuss of really just sort of, considering almost the next generation and the social conscience of things. Is there any closing thoughts of things that you would hope that designers but also companies might pick up, the mantle and try to sort of progress, even if, as we've alluded to, the first steps are going to be shaky. They're going to have scrutiny. In hindsight, will be always be 2020, I guess, is what I'm trying to say. But would you say there's some good starting points? Where would you apply your focus for companies and designers alike now?
I think the industry is going in the right direction, regardless of the state of the legislation and the directives. Um, there are groups that are, companies that are looking to collaborate and work together to deliver standards. So for battery packs, for power tool and the like, there's a Husqvarna Bosch standard
Hmm.
for an interface that's kind of sets everything out as sort of 18 volts. It's not perfect. It's not where, it's not what I would have designed if with a blank sheet of paper. It's probably not what they would design now with a blank sheet of paper if you look in front of it. But it's a great starting point. It's got
Yeah.
the right approach. It's in the right base with the right mindset. And it takes a shift in thinking, because then suddenly you're going to buy, your Bosch power tool, and you're going to buy any one of a number of
Yeah.
third-party packs to put on your product. So bringing out those kind of standards, takes a bit of bravery for companies, because
Mm.
it potentially impacts
Their bottom line.
their bottom line, right? Yeah,
Out
absolutely.
of interest, just for my own education, I think maybe some of the viewers, is this equivalent in battery terms to Apple releasing the MFI standard, meaning a company can legitimately interface with Apple products and say that it's certified, but they give them a kickback essentially financially?
That that's slightly different, right?
Okay.
So the MFI model is about allowing people into their ecosystem.
Yeah.
Um, it's done with kind of encrypted handshakes, and you buy an MFI chip, and you're signing up to a level of kind of
Being in the club, basically.
quality that Apple are willing to endorse, right? So it means Apple are endorsing that product, or that companion product for their ecosystem, which is great, right? It's a great approach. Um, uh, that kickback's quite small, really. If
Hmm.
it's not really a kickback they're making a lot of profit out of. It's there to allow them to run that scheme, because they've got to validate
Yeah,
every third party's device with their ecosystem. It maybe shuts down the very small players because it becomes a significant cost for very small
it's R&D
volumes.
intensive. Yeah,
Yeah, yeah.
yeah.
Um,
But sorry, getting
um,
back to Bosch and Husqvarna, you're saying it's less of a chipped thing and more of a design standard that's
yeah, it's a
universal, is
design
it?
standard.
Yeah,
It defines interfaces, connector positions, um, that um, kind of ski boot sled type connection.
yeah.
You will see it on not just Bosch products, but you'll see it on lots of products.
Hmm.
They've all adopted it. There are ways of tweaking it and working with it so that you shut your product down to only use your battery type, but actually, um, that kind of ecosystem allows people to buy products from Bosch and another,
Yeah,
um, you know, and have that kind of interchangeable architecture. So if you were a tradesperson, it's great news for you. It means that your whatever it is, Makita, or I don't know which ones comply with
sure.
it, but
But they're interchangeable is the point.
they're all
Yeah.
interchangeable. When you're up a ladder and you've got
Hmm.
four tools, it's a great thing, right? So
Yeah.
um so yeah, and it's it introduces its own challenges. It means that you have to regulate interface for products and product categories, and that's really what we need. If that was kind of EU, UK, US directive driven, um, it would move the world along so much better. That would be a fantastic thing to encourage to come about.
Hmm.
Um, you know, bodies like the IEC and the IEEE are fantastic for making those things happen. Um, similar. That's why we have a USB standard, right? And we have
Yeah.
yeah, you know, because the IEEE made it happen, right? Um, there's there's room for so much more. There's room for so much more in that space to drive the future forward, and it's a positive and exciting future ahead of us from a technology at kind of tackling these kind of problems.
Yeah.
Absolutely.
I sense that I'm due a phone call with the IEEE to ask how can people get involved now off the back of this discussion. So, but honestly, I think, to step back, I really appreciate you walking us through some of the complexities and sort of cautionary elements. But overwhelmingly, it feels like this is genuinely a really exciting time to be an electronics engineer, designer, and indeed brand manager and custodian of these sorts of new initiatives. So it's been really exciting talking. Thanks so much, Nathan, and good luck with the new venture.
Right, Jude, thank you so much.
Take
Yeah,
care.
cheers. Bye bye.
Bye bye.